Hello, this is Sabir. The topic of our discussion in this video is the limit of a function. In this video, we will discuss the two different methods of calculating the limit. In the first method, we will estimate the limit by a table, and in the second method, we will use the graph of the function to calculate the limit of the function. Let's begin with the first method, estimating the limits by a table. First, let's check what is the notation and what is the meaning of the notation of the limit. So, the notation of writing a limit of a function is a limit x approaches to a f of x is equal to some number L. So, it is meaning is that when I'm approaching to my input A, as x is approaching to the input A, the value of the function is approaching to the number L. Is not exactly is equal to the number L, but it is very near to the number L when my x is very near to A. Let's do this example to understand this concept a little better. So I'm x here. I have my x approaches to 1. So I can approach to 1 from the two side. If I approach to 1 from the left, I will write this negative sign on the top. It means I'm on the left side of 1. So what is the left side of 1? It will be 0.9, 0.99. So these are the values, some values of the input, which is near 1, but is on the left side of 1. So these are my x value, which are approaching, my input is approaching to 1 from the left, and I plug these value into my function and calculate the y value of the function. So I will plug into this function, which is x square minus 1 divided by x minus 1. So when I will do that, I'm going to get 1.9, 1.99, 1.999, and 1.999. So as I can see that these values, clearly the trend of these values are approaching to 2. So we can say that the limit as x approaches to 1 from the left side, the function f of x, which is x square minus 1 divided by x minus 1, the y value of the function are approaching to 2. So this is my left limit. The left limit of the function is 2. Let's calculate the right limit. So let's do that here. This is the 1. When I say right side of 1, I will just add a plus sign. So this will the notation of I'm on the right side of 1. So on the right side of 1, I can be 1.1, 1.01, 1.001, 1.0001. That should be enough values of the input. Now the input is approaching to 1 from the right. And let's see the output, which is the y value. If I plug that into the function, I'm going to get 2.1, 2.01, 2.001, and 2.0001. Clearly, these values, these y values are approaching to 2. So this means our limit, we will say that the limit x approaches to 1 from the positive side, it means on the right side of the function is also 2. Let's summarize with this example here, with this table here. So when I'm approaching my function or my 1 from the left, my value of the function are also approaching to 2. And when I'm approaching 1 from the right, my value of the function are approaching to 2. So when the left limit and the right limits are equal, then we say the two-sided limit. The limit x approaches to 1 when there is no plus and a minus. That means this is a two-sided limit is also approaching to 2. Here I have two more examples in which we will calculate the limit by using this method, estimating the limit by a table. Let's begin with the first example. So we first calculate 0 from the left side. So I will start with the minus 0.1, minus 0.01, minus 0.001, and minus 0.0001. And I will plug these values. These are max value. I will plug these values into my function, which is x sine 1 over x. Make sure that your calculator is in the radians when you plug these values. So since the R input is in radian. So here are my y values when I plug my x values into my function x sine 1 over x. As you can see that as the x values are approaching to 0, my y values are approaching to 0 also. So therefore, we will say that this limit as x approaches to 0 from the left of the function x sine 1 over x is equal to 0. Similarly, we can plot the table in which we will take the values uh, from the function from the right side of 0. As we can see also these y values also approaching to 0. So my right limit, the limit x approaches to 0 from the right of x sine 1 over x is also 0. Since the left limit and the right limit is same, so then we will say that the two-sided limit of this function is also 0. Let's begin with the next example, which is a sine 1 over x. So again, we will calculate the 0 from the left in one table, and in one table we will calculate the limit uh, from the right. We will approach the 0 from the left and 0 from the right. So if we approach the 0 from the left, I can start with the minus 0.1, minus 0.01, minus 0.001, and minus 0.0001. And on the right side, if I say it's minus 0.1, 0.01, 0.001, 0.0001. So let's get the calculator and plug these values into our function and compute the y value of these on these x values. So here after plugging the x value into the function or my y value, as you can see here, this very interesting trend. The function initially was approaching to 0, but suddenly it is going away from 0. The value y values are uh, going away from 0. So the trend of the y value is not consistent. Sometimes it's going to 0, sometimes it's going away from 0. So since the y values are not approaching to a single number or same number, so you say this limit is a DNA. So the limit from the left, let's say the limit 0 from the left, x sine 1 over x is a DNA. Similarly, if I plug these values on the 0 from the right into the function, again, sometimes the number are approaching to 0, some numbers are not approaching to 0. So they are not approaching to a fixed number. So we will also say this trend is not consistent. So the limit is a Dn. So limit x approaches to 0 from the right, x sine 1 over x is Dn. Since the left limit and right limit both does not exist, so the total limit, the two-sided limit will also not exist. So the final answer for this problem is also Dn. In our second method, we will calculate the limit of the function using the graph of the function. For example, Here we have the graph of the function y is equal to gx, and we would like to know what is the limit of the function at 1, 2, and 3. As I can see, when on the left side of 1, my function, when the x is approaching to 1, my function value are approaching to 1 also. So when on the left side of 1, this function, the graph of this function is heading towards 1. So I will say that the limit as x approaches to 1 from the left of the function gx is equal to 1. But when I'm on the right side of 1, the graph of the function, this is the right side, the graph of the function is approaching to 0. So this is a y value is heading towards 0. So we will say the limit x approaches to 1 from the right of the function g of x is equal to 0. Since the left limit is not is equal to the right limit, so that means the limit x approaches to 1, which is the two-sided limit, the g of x is equal to tne. So limit does not define, because on the right side of 1, the function is approaching to 0. On the left side of 1, the function is approaching to 1. So their trend is not approaching to the same number, so the limit will not exist. Here in the second, if I'm approaching to 2 from the left, the graph of the function is approaching to 1. And if I'm approaching to 2 on the right, the graph of the function is again approaching to 1. So the left limit is equal to right limit. So limit x approaches to 2 from the left of the function gx is equal to 1, which is also the limit x approaches to 2 on the gx. Since the two-sided limit, the left side and right side are equal, it will be therefore the two-sided limit x approaches to 2 of the function g of x is equal to 1, whatever the common value of the limit is. Let's look at 3. When I'm approaching to 3 from the left or from the right, my y value is always approaching to 0. So the limit, so in this situation, the limit x approaches to 3 from the left of the function gx is equal to 0, and the limit x approaches to 3 from the right of the gx is equal to 0. So since the left limit and right limit is same, therefore the limit x approaches to 3 of the function gx is equal to 0. Here, one thing to be noticed that the limit does not depend on the value of the function, even though the value of the function here is a 1, but the limit is 0, because the limit is the trend of the y value of the function when we are near x, because we don't exactly take the exact value of the function in the limit. Limit is when we approach to 1 from the left and right. So that's why the limit and it is the value, exact value of the function has no relation. Here I have another example where we will calculate the limit by using the graph of the function. So here in our first example, let's see, when we approach the 0, so this is a 0. If I'm on the right side of 0, it means on this side of 0, the graph of the function is approaching to 5. So this limit is a 5. 3, 3 is here on the left side of 3. So this is a 3. The left side of 3, I'm approaching to this. And you can see that the left side, the graph of the function is approaching to negative infinity. So this limit is negative infinity. The positive type 3 on this side, the graph of the function is approaching to this number 4. So that limit is 4. Then, so this left limit is not equal to the right limit. So this limit will be dne. the two-sided limit because the left limit is not equal to the right limit. Let's look at a 5. On the left side of 5, the graph is approaching to 2, so this limit is 2. On the right side of 5, the graph of the function is approaching to -3, so this limit is a -3. Since the left limit and right limit are not equal, so this will be also dn. Let's look at 6. On the left side, we are approaching to the infinity because the graph of the function is going up, and it will give you an infinity, which is a positive infinity. On the right side, if on the right side, the graph of the function is again approaching to plus infinity. So this time, the left limit and right limit both are approaching to a positive infinity, which is the same number, if it is a number. So the two-sided limit of the function at x approaches to 6 is infinity. Here I have one quiz problem for you to practice. The graph of the function is given, and I'm asking you to what is the limit of the function when x is approaching to 0. So once pause this video for 1 and 2 minutes, and once you have solved the problems, you can also leave your answer in the link above to compare with the other audience. In this quiz problem, this is quiz problem number 2, you have to calculate the limit as x approaches to 1 of the function. So pause the video for 1 minute, and once you are ready, you can leave your answer in the link above. I have one more question where you will calculate the limit of the function as x approaches to 3 of the function f of x whose graph is given below. So here is the overview of this video tutorial. So we study the one-sided limit, and we denote the one-sided limit with a negative sign on the top of C, and we denote the right-sided limit with a positive sign on the top of C. And we say that if the limit side, the left limit exists and is equal to the number, the right limit exists and it is equal to the same number, then the two-sided limit, where we do not write any positive or negative sign on the top. So that means it's understood that this is a two-sided limit. And the two-sided limit only exists when the left limit and right limit both are equal. Here I have a learning activities which you can do at home to practice calculating the limit using the graph of the function. This activity I have taken from the book Tactile Learning Activities in Mathematics by Julia and Jessica. To do that activities, you need two pieces of paper. So what we will do that, let's we want to calculate the limit of the function as x approaches to 0 of the function f of x. So we will put one piece of the paper on the left side of 0 and hide the function which is on the left side of 0, because we are not interested in the function which is on the left side. We are only interested in the branch of the function which is on the right side. And then you move your right piece of the paper, you approach basically 0 from the right side, and then you see that where the branch of the function is approaching. So as you can see here, your function is approaching to 0. So that helps to remove the confusion, because when the graph of the function is too big and there's too many branches of the function has, so this will basically help you to see that where the function, the graph of the function is approaching to near the right side of 0. Um, Here, let's do the two-sided limit with this activities. What we will do two-sided. So we're gonna approach 0 from the two sides. So I will put the two piece of paper on the both sides and start approaching to 0 from the both sides in the same time. As I can see, the graph of the function is approaching to 0. Both the branch, the left side and the right side, both are approaching to 0. So we will say this is the limit is also 0. Similarly, you can check what is the right side of 1. So I hide the graph of the function which on the left side by a piece of paper, and then we approach the right side of 1 from this piece of the another piece of paper, and we can see that this limit is approaching to 0. So this limit is also 0. Similarly, you can approach 1 from the left side, and so you hide the function, the graph of the function from the right with the piece of paper, and then you approach the left side with another piece of paper. So in this, we can see that this limit is approaching to 1. So this is approaching to 1. So as if we want to calculate the two-sided limit at 1, so you can see that if I'm approaching the both side of 1, the my y value on the left is 1, is approaching to this value, and my right is 0. So the both values are not equal, or the graph of the function is basically have a jump. So this says the limit does not exist in this situation, and this has nothing to do with the value of the function, which is 2 situation. Here I have one last the quiz problem. The quiz problem number 4. So take the two piece of paper and calculate the limit of the function as x approaches to -1. So pause the video for 1 and 2 minutes, and once you have the answer, you can leave your answer in the link above to compare with the other audience. This is all I have in this video. If you like the video, subscribe my channel and hit the bell button so you can get the next video. I will see you in the next video. Bye for now.